In this lecture, I want to explain blockchain. Let me first define blockchain and listen carefully because blockchain definition is very difficult to understand. Are you ready? Blockchain is a chain of blocks. The first block was created in 2009 by a mysterious figure known as Satoshi Nakamoto. And nobody knows who Satoshi Nakamoto is. He might be a girl, a guy, a group of people, or some organization. I recommend you look him up. A new block is being added in the blockchain after every 10 minutes in average. A new block is linked to the previous block created before it. So in this way, all the blocks can be traversed and we can reach to the Genesis block. Let's zoom in on a block. Each block has two parts, a header and body. A body has a set of transactions. In this case, the block K has a transaction TK1, TK2, TK3 and so on. A transaction refers to transfer of digital coin by the owner to another person or persons. Transaction has two key components. Number one, the amount to send, and number two, public key of the receiver. Using public key instead of the real identity of the receiver, transaction tends to provide privacy. For example, if you want to send me $1 billion, then you can send me 130,000 bitcoins and use my public key XXX. In Bitcoin, transactions are also linked together, but we will come back to it later on. Let's take a closer look at the content of a header. One of the important things the header contains is a hash. This hash is the hash code of the previous block's header in the blockchain. For instance, this block has the hash of this block header, and this link is created because of the hash code. And this block will have the hash code of this block's header, and this link represents that hash code, and so on. For instance, if any of the content of the header of block K plus 1 is changed, then this link, this hash stored in the block K plus 2 will become invalid. And we have to recompute the hash stored in K plus 2. By recomputing the hash stored in K plus 2, we will change the content of the header of K plus 2 block. And that means that this link will become invalid. And we have to recompute the hash stored in K plus 3. This implies by changing the header of any block, we have to recompute hashes of all the blocks that come after that block in the timeline. Another important information stored in a block header is Merkle root. Merkle root is the root of a Merkle tree whose leaves are the hashes of the transactions stored in the body of a block. Assume that the block K has 8 transactions. Then the Merkle tree will look like something like that. So basically H1 is the hash of the first transaction, H2 is the hash of the second transaction, and so on. So we have this whole Merkle tree, and the root of the Merkle tree is stored in the header of the block. Please refer to my previous lecture to know more about the Merkle tree. So assume that a transaction in the body is changed, and because the change in the transaction, the Merkle root stored in the header becomes invalid. And as the Merkle root becomes invalid, we have to change the header. And when we change the header, then that means that this link becomes invalid, and then we have to recompute the hashes of stored in all the blocks. So the Merkle root protects the transaction stored in a body of a block while keeping the size of a header small. And because the size of the header is small, so computing these hashes is fast because these hashes are of the small header instead of the hashes of the whole block. There is another key advantage of storing Merkle root in the header. To explain that advantage, first I have to answer two questions. Number one, who stores the blockchain? The answer to this question is everyone who has a large enough storage can store the blockchain. At the moment, the blockchain takes something around 3 terabytes of storage space. So usually the researchers and the miners are the one who are storing the blockchain. The second question is how the blockchain is stored. Answer to this question is that the blockchain can be stored in two different ways. A person or a company that is storing a blockchain is called node. And we have two kind of node. We have a full node. Full node refers to a person or a company that is storing the full blockchain with a header and a body. Every block is complete. And we have a partial node. Partial node refers to a company or a person who is only storing header of each block in the blockchain. Because the header size is extremely small as compared to the size of body, partial nodes require significantly less storage space as compared to a full node. A full node can verify content of any block because it has all the information available. It can recreate a Merkle tree, it can compare the Merkle tree created with the Merkle root stored in its header and everything. Because of the Merkle root stored in the header of each block, a partial node can also verify transaction without having to store any transaction locally. To accomplish that, the partial node has to communicate with a full node and fetch log information from a full node. Please once again refer to my previous lecture about Merkle tree. In the next video, I will explain the working of Bitcoin and also how the Bitcoin consensus mechanism works. So stay tuned.